Hi all, I'm Hariharanus.
My name is Rosdanis.
We are representing TKM CPS and we are Team Phoenix. Project is double-decker Maglev trains. So, as people, we have various needs. One of the most important needs that we serve is the mode of transportation. To understand my exhibit a bit more, I would like to put forward a certain scenario. Let's say you have to travel between 2 points, point A and point B, and you have a distance of 360 kilometers between them. So, what would be your mode of transportation? So, let me break it down for you. Immediately, we can rule out the possibilities of using a four-wheeler or two-wheeler mainly because of the large distance to be covered and traffic has to be considered. Then you could suggest me trains, which is also viable mode of transportation, but due to them not being energy efficient, we can cancel them out as well. Now, what else is there? Yes, aeroplanes. But as I said before, there are lots of people are there. So people are from various different economic backgrounds. So it might not be the cup of tea for everyone to take aeroplanes. This is where my exhibit comes in, Maglev trains. So what are these Maglev trains? Maglev trains are trains which utilize superconductors for moving. They use the property of magnetic repulsion for moving across tracks. Now let's understand a bit more. So this is the heart of such trains, superconducting electromagnets. So what are these? So first let's try to break down what is the superconducting. Superconductive nature of metals are when metals are cooled down to certain temperature, they show a property where they lack or they have no resistance, zero resistance. So there will be a high amount of power supply and also they are having a very large magnetic field. So as you can see, this is a magnet here and this having a superconductive nature. So this is very useful in such scenarios because there's a large power supply and also a very large magnetic field to be utilized for the repulsion property that I've said before. Now let's see. So this is how an actual technical and engine of such trains work. As you can see, there are 4 magnets arranged like this in the system, and actually, as I said before, they need to be maintained to a certain temperature, which is done by such liquid helium cylinders. As you can see, they are attached to the magnets which cool them down for this purpose. Then they are kept in this chamber. So this is done because in this condition itself they can radiate heat. So due to protect them, there is this chamber, and to cool down the chamber itself, they use liquid nitrogen. Now let's move on. As you can see, such engines are attached all across the sides of the vehicle. Then as you can see, there are seats so the passengers can sit, and these are like the external skeleton of the train basically. There are 3 main objectives that the train need to attain. That is propulsion, levitation, and guidance. All these are maintained through certain magnets which are kept here. As you can see, these guideways are filled with coils and electromagnets which help to maintain these three main things that you need to achieve. That is, it is done through interconnecting. As you can see, the guides here, interconnecting electromagnets. And so how it works is that, as you can see, the train comes. Let's assume this is a train. So this is the path, and when the train comes, they align with this path. That is, if this is having a north pole, they interconnect each other to have the same paths having the same like pole to it, the north and north, which would make a repulsion, which would make the train move forward. This is how the propulsion is attained. Similarly, with almost same technology, all these 3 objectives are attained. Now let's move on. You can see this is how they work. So there are propelling coils installed in these guideways. How they work is that, as you can see, the train as it's moving by, they interchange the poles. So as you can see here, as they are connected between, as the train moves, they are interchange the poles. It will be shown in a moment. As you can see, right, they change the poles, north to north, south to south, north to north, south to south, which would provide a propelling force for the train to move forward. And this is happening on both the guideways, which would help the train in the movement. So these are the advantages or disadvantages of maglev trains. There are large amount of advantages. Some notable ones are high level of safety, low maintenance cost, less space, energy efficient, weatherproof, etc. And there are also disadvantages, as everything. High initial cost, lack of existing infrastructure, and high fare. Now, as our team, we have done a lot of contribution to this. Now let's check it out what that is. So this is our contribution to it. So what is our opinion on the high initial cost? So yes, there is a high initial cost to this project because there is a lack of infrastructure. So our opinion is that even if we are spending a large amount on it, in a long term we are going to have an energy efficient, eco-friendly, and a very fast way of transportation between 2 cities of very large distance. So it's in the end a very profitable situation. Then is the use of lightweight material. So in this, so like when vehicles, in small vehicles or something, the use of a high lightweight material something does not that much matter, because they have to be using heavy duty metals, because in the end it is also to safety and all. But in the case of here, the only objective, that one of the important objective that we have to attain is high speed. So by the use of lightweight materials in the seating and many other things which is done in the train, it could attain a very high more speed, because there is less mass to move through the air. Now next is reduction of fares. So how can we do this? Even though they are having a high fare, this fare can be mainly reduced by increasing the number of seats or using a less quality material inside the train itself, like for the seats and all. Now then, this is one of our project's talking points, that is harvesting electrical energy from air drag. As it is, it does not make any sense, but let me explain it to you. So basically, as a train levitates, there is only one force which is stopping its motion, that is air drag or air resistance. So basically how this moves is that it literally creates an air pocket in the air to move through it. Now in this, air resistance is created and it creates a lot of temperature and heat on the surface of the train. And now using piezoelectric nano generators, you will be using this thermal energy to convert it to electrical energy, which is have a very important application. I said before about a pump which is cooling all the liquid helium and the liquid hydrogen, nitrogen and all, right. So to maintain the pump of this, we are going to use this electricity, and also for the working of the train, it requires exciting charge to start it again. So we could also use this electricity for it, and also this electricity can also be harvested from the engines themselves. Now next is one of the talking points on the heading of a project itself, double-decker Maglev trains.
As you can see here, this is the model and structure of an already existing double-decker metro series from Japan. Now, why I'm suggesting such a double-decker model is mainly because of the fact that one of the biggest disadvantages of such a maglev train is the high fare per seat. Now, when we are introducing double-decker to this, the seats would almost get doubled. Due to it, there will be a drastic decrease in the fare per seat. Now, this drastic decrease will make the seats available for a larger section of the society. With this, a lot of people are being given the opportunity for a cheap, very hyper fast, and a very comfortable mode of transportation. With this, I would like to conclude my presentation.
This is our exhibit.
We have made this with the principle of magnetic repulsion. As we can see, now we can see the repulsion and levitation under it. The magnetic repulsion is happening because we have attached the magnet with the like poles. As we can see now, it is north pole and it is north pole. It is south pole, this is south pole. That's why it's repelling. We have made it with the like poles. In the real world, the magnets are applied or are kept on the side of the guideway. But for maintaining our structure, we have kept or we have attached the magnet under the guideway, so it will move smoothly.
So in an actual real life situation, how the trains work is that they have wheels underneath them, and then after a while only, after working with the wheels, after a while only they start levitating and moving across the tracks. I am the idea creator,
And I am the mechanical lead.
hope this idea will help the world. Thank you.